This concludes our checks using ACI 530-13. But at this point, you've learned how important the F'(m) or the masonry compressive strength value is to the design process. Because we aren't using a common brick or CMU masonry for the ramp walls, we'll use some exterior research to adjust our F'(m) accordingly. Remember, this can be up to 10 megapascals normally, but we are going to start with a conservative value of 1.5 megapascals. Table 4 in the study, one of the studies linked below, for stone rubble masonry, tells us that we have a worst case 3.3 megapascal compressive strength for stone rubble masonry that's less than 60 centimeters in width, and a similar elastic modulus with a worst case shear strength of 22.6 psi, which is quite close to our value of 22.12 psi that we get from the allowable shear strength check in the code. And from a few other research papers, we see values of F'(m) commonly between the range of 3 to 10 megapascals. And we are taking a even lower value than this, partially because the mortar is being hand mixed in the field, and we are unsure, we don't have perfect curing temperatures, and we're unsure of how well the masonry, the grout is actually getting up in the masonry and forming those bonds. So we're going to take a really conservative value of 1.5 megapascals for our F'(m). And then I also added a few extra terms in here for you, just for the purpose of identifying masonry parts. We have, a unit is going to be a single brick or rock in our case. A course is going to be a horizontal row, if you will, of masonry. A withe is going to be a column of masonry. And then we have our bed joint, which we discussed a bit earlier, which is going to be the joint that the stone or the brick lays down onto. And we have our head joint, which is going to be the joint between units in a course.